Good morning, everybody. Hope everyone's doing good today. A couple more seconds here. All right. I think we should go ahead and get started. The content I've got today might take us right to the end of the hour, so don't want to waste any time here. Just want to start off by saying I really appreciate you guys joining us today. Those of you that have attended past webinars, appreciate you guys coming back, and new folks that are jumping in just for the webinar today, really appreciate you spending some time with us here. Looking forward to sharing some of my knowledge about different extraction processes, give you guys a brief comparison, hopefully give you a little bit of information that helps you understand the differences, the plus and minuses between hydrocarbon, CO2, ethanol, and mechanical extraction processes. So my name is Zig Xavier, outside sales manager here at Hal Extraction. I've been in the industry since about 2013, right before the adult use boom in Colorado and Washington. And I've spent a good amount of time since then, either working directly in extraction facilities or doing consulting for extraction operations. And so I want to take some of that anecdotal and experiential knowledge and kind of share that with you guys today. Do want to take a brief moment to just let you guys know who Hal Extraction is. I'm sure most of you guys are familiar if you're here in the webinar. For those of you that are not familiar with us, we're essentially a group of extraction experts, engineers, and safety experts that have designed and created modular extraction rooms for the cannabis extraction industry. So CID1 and CID2 extraction booths that are UL listed and PSI peer reviewed. So if you're in facility design phases, looking to expand your operation, your production throughput, give us a shout. We can help design your facility. We can help, get you up to code, pass inspections, all that good stuff. So we're really here to help the manufacturing extraction folks in the cannabis industry. We also do plan on doing some more of these webinars. So if you guys want to follow us on social media channels, that's probably the best place to track upcoming topics. Hopefully after today, we'll either do a kind of part 2 of processes, so adding in some other ones, maybe some post-processing descriptions, but also I'm looking to start doing some collaborative webinars and have some of our equipment partners or other consultants join us and share some of their knowledge. So might be doing some deeper dives, for example, into just supercritical CO2 in the future. So keep an eye out for those on social media. So as the title alludes to, what we'll be going through today is a comparison of hydrocarbon, CO2, ethanol, and then mechanical or rosin extraction processes. Start by doing a high-level overview, describe what each process is, how it works, without too much detail, but it should give you guys a good idea of what the nuances are in the production methods for these different processes. And then I'll move into what you can expect from a product perspective. So kind of the plus and minuses of each process and why certain processes are better tailored towards certain products or consumer biases. And then, because we are a safety-focused company, I will touch briefly upon the hazards of each process, kind of where the dangers lie with that particular extraction method, and kind of which ones are the de facto safer or more dangerous ones. Then move into a little bit of a cost overview, really focusing on facility design costs, the actual equipment and unit costs, and then moving into kind of operational costs, our ongoing expenses specific to each extraction process. Then I do have a little final comparison that'll really just summarize everything I go through today. And then I'm happy to open the floor up to any questions if you have some time, and see if there's anything else that you guys wanted me to touch upon today. So if you guys do have questions, there should be a chat function you can throw that up in the chat function, and I'll go in the end and kind of look through what those different questions are. All right, so starting with hydrocarbon extractions. I think these are kind of viewed as one of the more popular extraction methods out there, commonly referred to as BHO, butane hash oil. But hydrocarbon extractions really do involve any extraction process that uses hydrocarbons as a solvent. So if you see propane, butane, hexane, pentane, I mean, a lot of the anes are used for the extraction process because of their polarity and the way that they interact with cannabinoids and can extract those substances from plant matter. So up here on the screen, got a couple different generic closed loop systems. I do want to mention in the past, most butane oil extraction was done through open blasting, basically a canister or tube with butane being forced through it, and that butane would then be off-gassed into the atmosphere. Luckily, the industry has moved to a more safer process to where now it's a closed loop contained system. So not only are those safer systems, but they actually are a lot more efficient in that you are able to recover the majority of the solvent they use for each run. And so the basic premise of hydrocarbon extractions, we did put together this nice little diagram. Not quite an artist, but let's give you an idea of kind of what the process looks like. And they really boil down to kind of three main components. One of those being the hydrocarbon vessels, so kind of the initial output vessel, and then the recovery vessel, and then you have the loaded extraction vessel, which is really where your plant matter is before it's being processed, and then you have a collection vessel where you can actually remove the hydrocarbon and cannabinoid mixture from your closed loop system before loading it up, disposing of that spent feed and preparing the system for another run. And so, like I said, very efficient. Hydrocarbon runs are typically a lot quicker than, let's say, supercritical CO2, and about on par with ethanol washes. So a lot of systems, you can get a full run done in about 30 minutes. I think BHO is nice, or hydrocarbon extraction units, I should say, are nice because they do scale well. You can add additional plant feed columns and continue to process through and essentially just increase your throughput by adding more material columns into your unit and your system. That being said, they do tend to, because hydrocarbons, the way they interact with plants, they will strip both desirable and undesirable compounds from your plant matter. So you'll get, your cannabinoids, your terpenes, but then you also get some lipids and waxes or cellulose, other kind of undesirable plant materials that may end up in your final product. So that's why you see a lot of folks using fresh frozen material or high quality flour for their hydrocarbon extracts. It's kind of the old, you get out what you put in essentially. So if you use high quality flour, you're going to get high quality extracts out of your system. But you can also use hydrocarbon extraction units to really kind of just brood out any sort of cannabinoids that might be remaining in biomass or older, less desirable trim, and then take that kind of crude BHO extraction and put that through post-extraction refinement processes. So using a short path distillation system or a thin film distillation system to isolate those cannabinoids and desirable compounds from the less desirable compounds. So it's not as much of a selective process. You really just kind of run the system, you take the extract out, and then again, depending on the quality of the plant matter that you're putting in there, you may have to do some post-extraction refinement, or if you're using some high quality flour, you can generally just go through the final purge processes, and you have a nice consumer ready product, essentially right out of the extraction unit. So I think supercritical is quickly rising in popularity, especially as we see the hemp industry, kind of hemp 2.0, come online and more, larger production goals and throughput goals for a lot of CBD, but also kind of these larger multi-state operators and folks that do have higher production goals for their THC licensed businesses. Supercritical CO2 is interesting in that it uses carbon dioxide to separate cannabinoids and terpenes from the raw plant material. What the process essentially consists of is taking your CO2 gas. Actually, let me move to the next slide here. So it essentially takes CO2 gas and then through a process of pressurizing, cooling, and then reheating that gas, you get it into a supercritical state. Supercritical compounds, they can pass through solids essentially like a gas, so they're very permeable, but they are able to strip compounds from those solids like a liquid would. They have kind of an all-encompassing, let's say, aspect to them. So they're able to pull those cannabinoids and those terpenes from the plant matter very effectively and efficiently. Supercritical systems, just like BHO and hydrocarbon systems, do scale well with your facility. So they can be kind of as small as you need or as large as you need. As we saw on this last slide, we have a massive production scale system over here on the left, and then a little bit more of a standard kind of smaller facility supercritical system over here on the right. And they function very similar to hydrocarbon systems in that you have a solvent, as you can see in this diagram here. You have your solvent, your CO2 tank that moves through that condensing and heating cycle to become supercritical before passing through plant matter columns, extracting those cannabinoids, the desirable, let's say, compounds from that plant matter, and then depositing them into a collection vessel for you to remove from the system. After that extraction has happened, you can depressurize and off gas, and similar again to the hydrocarbons, recover that CO2. So there's a decent amount of efficiency when it comes to the amount of solvent that's needed for these processes, because you are able to recover by and large most of the solvent used per run. So supercritical processes, they are fairly efficient. They're not going to be quite as efficient as far as kind of speed per run as a hydrocarbon system, because of that pressurization and turning the CO2 gas into a supercritical fluid does take a little bit of time. But beyond that, the runs are largely going to be fairly similar to your hydrocarbon units. But the selectivity is I think really where supercritical CO2 systems shine. The way that supercritical fluids interact with compounds can depend on, you can basically manipulate kind of how that supercritical fluid is interacting with plant compounds by either increasing the fluidity, kind of the liquid aspects of it, or increasing the more gaseous aspects of it. So you can actually target in each run specific compounds in your plant. So that makes supercritical CO2 really good for taking, let's say, lower quality plant compounds or plant matter, and then setting the fractions to actually target specific cannabinoids or terpenes from those plants. And you're able to extract just those desirable compounds while leaving some of the undesirable compounds behind. And you can do that over and over for the same run until you have multiple different fractions of that same extract. So, it allows you to take kind of less desirable plant matter and then extract it into better ones. All right, so moving along here, we're going to do some ethanol next. So I think similar to CO2, the rise of the hemp industry and kind of the need for higher throughput processes here, we're seeing a lot of folks start to adapt really large production scale ethanol systems like you see over here on the left. And the throughput that you're able to achieve with these systems is much greater typically per run than CO2 or hydrocarbons. So there are there's no pressurized systems, no gases or solvents besides the ethanol being used. So typically what this entails is you put the plant matter in an ethanol wash vessel. You allow the ethanol to actually leach out all the cannabinoids, but often some other compounds as well. And then you can take that raw crude ethanol oil, what's been extracted, and pass it through a post-extraction refinement process like we see over here with this large rotovap to separate the cannabinoids from the less desirable compounds. So from a process perspective, very simple systems. You essentially, and, you don't necessarily have to have a compressor, but you have to have a method of essentially moving your ethanol from the ethanol storage tanks into your extraction vessels, where it interacts with the plant matter, moves from that extraction vessel into a collection vessel, where you can then have the ethanol be recovered. So again, kind of a closed loop system here, and then have the extracted cannabinoid compounds, the crude oil, be pulled out of the collection vessel and then passed through secondary processing. And so I do want to focus on the secondary processing here because I think ethanol is it's the only process that really requires post-extraction refinement. Ethanol crude oil is not a desirable consumer product. I think folks used to use, or I mean, I'm sure some folks still do, make, like Rick Simpson oil and things like that, really high cannabinoid content oils that still has a decent amount of residual ethanol in it. And so I think it's better to really go through that post-process refinement, distill it down to individual cannabinoids. And then from there, you're able to make a lot more consumer-friendly products, whether or not those are edibles or vape pens, or other things that might do well in your particular market. And so what that means is that ethanol, its big strength, I think, is the effectiveness and how quickly you can extract compounds from the plant matter. But you really do sacrifice some selectivity by doing so. You're really just kind of brute forcing out all those compounds, desirable and undesirable. And so there's that post-process refinement that needs to occur whenever you're doing an ethanol extraction. And that's another reason why I think ethanol is so popular in the hemp and CBD industries, because a lot of the time that biomass in the plant matter you're using is not going to be considered, a high-grade smokable flower, for example. So you can take your trim, you can take your less desirable plant matter, and then squeeze out any potential product from there and get the most bang for your buck when it comes to cultivation costs. All right, and then the final process I want to touch upon today is mechanical processing, really commonly referred to as rosin. So this process is very straightforward. It involves heat and pressure to quite literally squeeze cannabinoids and terpenes out of plant matter. And then you use a sieve. You guys can see over here on this right-hand picture, there's a stack of these tea bags or little filtration bags that you put your plant matter in, and you can prevent the plant matter from coming out with your high-quality extract that you see over here on the left. So I think rosin extracts have gained a bit of a cult following over the last few years because there are no solvents being used during the extraction process. I think a lot of folks find that desirable. And also further refinement of kind of a water hash extraction process, which actually might be a process worth touching upon for the second part of this webinar, and turning water hash into something that's a little bit more easily vaporized. A lot of consumers like to dab or smoke vape pens, and water hash on its own is not necessarily the best at melting down and vaporizing. So rosin makes it a little bit more interactable for the consumer. That being said, because of the way that this is extracted, it is fairly nuanced. It takes a lot of time. So it's not really well suited to massive production goals. You can create some high quality, let's say like kind of luxury solvent-free lines. You can make vape cartridges or solvent-free edibles. But I think a lot of the time, if you have really big production goals, rosin is not going to be, or you're not going to want to have rosin as your sole method of extraction. So put together another fantastic art piece here for you guys. That being said, rosin is very straightforward, so there's not too much of a concept to understand here. You basically have a rosin press, which contains 2 heated pressure plates. You have your sieve bag with flour or water hash in it, and then you slowly squeeze at a decently low temperature, around the low 100 Fahrenheit range, and you squeeze out the cannabinoids quite literally through pressure, and you can collect them in typically some parchment on the side. And that can be directly consumed or again put into other products. So because there is no solvent being used here, there's no need for further purging or post process or post extraction refinement. So I think one of the main issues with mechanical extraction is going to be the efficacy of and the efficiency, not the efficacy, sorry, the efficiency of it. Again, not really good for massive production goals. A lot of the higher quality rosin producers will tell you that each press, each run is very nuanced in how you want to manipulate your pressure and your temperature. So it really is an active extraction process. Typically, you want to have a technician or someone experienced with the process right there, actually watching it happen, so they can kind of control the temperature and pressure variables as you are performing the actual extraction. And the selectivity is debatable. I think, I say it's sometimes selective, sometimes it's not. It's selective depending on what you're looking to make with your rosin. So again, because no refinement is needed for it to be a consumer-friendly product, you could argue that's selective in that way. But it's not selective in that you can choose kind of which compounds and cannabinoids and terpenes to actually extract from your product. You can manipulate the temperature a bit to control levels of various compounds coming through. But a lot of time you're going to get that full profile of terpenes and cannabinoids in the flower. And so rosin, similar to hydrocarbons and BHO, if you are going for a direct-to-consumer kind of dabbable product, you're going to be wanting to use high-quality flower or water hash to get that high-quality extract out. All right, so hopefully that gave you guys a quick idea of the 4 different processes and what they consist of. From kind of a process management point and a efficacy and selectivity point. I do want to touch upon the different products. I think that's the kind of one of the main differentiators between all these processes, really what you can expect to make with that extraction process. So starting again with hydrocarbon extracts here. As I mentioned, because you can directly purge out any existing or remaining solvents from your hydrocarbon extract, either through vacuum or heat or agitation. You can see on the left, these are kind of the different types of dab-ready hydrocarbon extracts. You have shatter, you have waxed, you can have kind of more crystallite, live resin, diamonds. I'm sure everyone has heard all the different names out there on the market. But essentially, those are all going to be hydrocarbon extracts that are then manipulated post-extraction to create that final consistency. And what you can do as well with hydrocarbon extracts is actually, this is something you can do with all the extraction processes, is perform that post-extraction refinement, isolate certain cannabinoids or compounds from your extraction mixture and create distillate or, let's say like THC isolated dab pens or CBD heavy vape pens, things like that, to create kind of a more targeted product for a specific market segment. So there's a little bit of variability in what you can do with your hydrocarbon extracts. I think, I didn't put edibles up here. I do have edibles on the CO2 and the ethanol pages, but I do think that CO2 and ethanol processes are typically better suited to creating the amount of extract you need for like a high throughput edible operation. And so some folks do use hydrocarbon extracts for their edibles, but I think if you're setting out to do just edibles, you'd be better off suited going with ethanol or supercritical CO2 as your extraction method of choice. So supercritical products, similar to BHO, you can create dab-ready products, waxes and shatters from CO2. I do think that the consumer typically prefers the hydrocarbon extracts because you get a little bit of a richer profile with the cannabinoids and the terpenes. CO2, because of that selectivity and the different fractions and ways that you're extracting specific compounds from your plant, you're not going to get that holistic and kind of synergistic effect of all the different cannabinoids working together quite as much as you would with your hydrocarbon products. But you can create dabbable products. But I think supercritical products are more well suited to be edibles or vape pens, again, with that post-process refinement. Or I got over here on the left, actual just terpenes that are isolated. And because those fractions in the supercritical CO2 processes, you can target just terpene extraction from your plant matter, which is tough to do in hydrocarbon processes. You can if you have a terpene trap, but it's kind of an additional piece of equipment. Whereas with supercritical CO2 units, you can identify and selectively target terpene extraction, so you can package terpenes up to be sold. I think those are typically products that are more desirable in a little bit more mature markets as people understand what they're looking to dab and kind of the different flavor profiles they're looking to get out of their extracts. But at that same time, it is worth mentioning that you can do that with your supercritical CO2 extractions. But I do really think that edibles is where supercritical CO2 shines. But ethanol does give supercritical a decent run for its money when it comes to the edible throughput and like efficacy areas. And so I mentioned already, but I will say it again. Ethanol is different than the other three processes we're talking about today because you really must do that post-extraction refinement. You can see over here on the left, the crude ethanol oil. It's not a desirable product by most consumers. So you got to put it through the distillation process like we see on the third image from the left here, that short path distillation unit. There you have the isolated cannabinoid compounds that you are putting into a jar to then put into either edibles or vape pens. And so ethanol is really good for high throughput facilities. If you have a lot of production goals, ethanol can be the best for you because you can get those cannabinoids out quickly, put them through the post-extraction refinement process, and then you have a lot of compounds available for your product development. And then rosin is the final one here. Again, rosin, I think, is kind of the least flexible when it comes to the type of products you make. A lot of time, folks, when they're setting out to do mechanical extraction, their goal is to make just rosin. So just kind of a dabbable product like we're seeing here on the screen. So kind of a sappy shatter consistency. You can cure it and make it a little bit more waxy. So really, again, depends on kind of the nuances of the post-extraction refinement that you put kind of each run through. But again, some companies do have solvent-free or, are dedicated solvent-free companies that are making vape pens and edibles out of rosin extracts. I just, again, think that the scalability and the efficiency of that process makes it tough to really have this be kind of a process that can support larger production goals. All right, on to safety here. So as I mentioned at the beginning, HAL is a safety-focused company. That's our primary goal, is making sure that extraction companies can get licensed because they have safe facilities and that their employees are able to make it home. So do want to spend some time talking about the hazards of each process. So we'll stick to our order here and start with hydrocarbons. So hydrocarbons do use the most volatile solvent. I'm sure most of you in the room have read or heard about the smoke chokes incident a couple weekends ago out in LA. They weren't, of course, a licensed producer, but they were a smoke shop supplier of sorts, and so they did have a bunch of butane stored in their facility. There was a fire, and that stored butane proceeded to explode because the fire acted as the ignition source for it. So there are inherent dangers with using hydrocarbons. These solvents are, flammable. They're stored under pressure. They have relatively low flash points, so they can ignite very easily and turn into explosives. But that being said, modern equipment and processes have largely eliminated these hazards. So any hydrocarbon extraction facility is required to have dedicated control areas with proper ventilation and sensors in place to prevent collection of any off-gas solvents, prevent any ignition sources from being present in that room, to essentially eliminate the hazard of using hydrocarbons as a solvent for extraction processes. And that being said, a lot of companies do have that post-extraction processing that occurs. and there will be residual solvents present in those extracts. And so I really do urge folks that I work with that do want to do hydrocarbon extracts to make sure that they have good training in place and kind of heightened awareness around those hydrocarbon extracts, even once they've exited that control area. So if you're putting them in a vacuum oven, you want to make sure the temperature typically will remain below 120 degrees Fahrenheit, so you're not creating any flash hazards for the off-gas butane in there. Please don't use a heat gun to try to quick purge any butane or hydrocarbons from your extract. That's the ignition source. It can blow up right in your face, and it's not something you want to be a part of. And, just for a shameless plug for HaltHair, we do create those control areas where you can have the ventilation and the sensors in place to prevent these hydrocarbon processes from being too dangerous. So moving along, supercritical CO2, inherently, this is carbon dioxide. We all breathe it out into the atmosphere. So of course, inherently carbon dioxide is a little bit safer of a solvent to use than hydrocarbons are. That being said, there are still some hazards associated with supercritical CO2. I think the main hazard would have to be the fact that there are extremely high pressures being generated inside supercritical CO2 units. So if there were to be a rupture of a pressure vessel, that could cause a pretty significant explosion. We don't want metal flying everywhere or extract flying everywhere. So that's something to keep an eye out for. So using eye protection, for example, is definitely warranted in supercritical CO2 facilities. And there's also the risk of suffocation, asphyxiation. So CO2, we breathe it out, but we can't breathe it in, or we can, but we need oxygen to survive, obviously. So if you are in an environment that's saturated with CO2, it can be hard for you to find that oxygen you need. And that's when you can start showing signs of carbon dioxide toxicity. And so if you're feeling drowsy, if your muscles are aching, kind of slurred speech, these are all signs to watch out for in a supercritical CO2 environment. It might mean that there's too much CO2 present in the atmosphere. So if you do have a supercritical CO2 process or operation, having some CO2 sensors could be a good idea, just to make sure that you are keeping the atmospheric percentages of CO2 below the limit at which CO2 toxicity would start to develop in your employees. Okay, so ethanol does have kind of a combination of hazards. Ethanol does exist in a liquid form, typically at room temperature, so not quite as hard to manage as hydrocarbons are, but it is a flammable liquid. So while most hydrocarbon facilities do require a CID1 space for those processes to occur in, ethanol is going to require a CID2 space, which does have some similar protection in place, reducing the amount of ignition sources and kind of spark proofing the area. But it does have a lessened requirement on the ventilation and the way you move air from that control space out into the ambient air around it. But you do need to have spill controls in place. So if there were to be a big spill of ethanol, you have buffers in the room that prevent that spill from spreading to the rest of the facility. Because if that were to, of course, catch fire, you want to be able to contain the ethanol in a specific space and not allow the fire to grow and kind of spread to other parts of your facility. So just making sure that you're controlling any potential spills and also keeping an eye out for ethanol vapors. While it does typically exist in liquid form, it does boil off relatively quickly. And so it creates ethanol vapors. Those can be toxic to inhale and cause short and long-term kind of side effects for your employees. So controlling the amount of ethanol vapor in the atmosphere in your operating room is going to be key to safety too. Then we have mechanical. Hazards here, as you can imagine, are fairly limited, but they do exist. So we do have crushing hazards because you are using a press to actually compress that plant matter and squeeze out those cannabinoids and terpenes. There is a risk of crushing, so you want to make sure your hands are out of the way of that. And the plates that are used in the rosin presses are heated as well. While they typically are at a relatively low temperature, again, similar to the vacuum ovens for hydrocarbons, let's say kind of the low 100-degree-Fahrenheit range. If you were to leave a piece of equipment or have a stray wire or a piece of plastic on there, that could melt down, not only damage your equipment, but ignite and cause damage to the area around it. So there are some burn hazards and kind of hot material hazards when it comes to mechanical and rosin extraction processes. All right. And then the final area that I really wanted to compare all these four processes in is going to be the costs associated with running operations, adopting each one of these extraction processes. So, little disclaimer, just general estimations from my experience. I didn't want to include any hard numbers in here because the hard unit cost will vary based on the production throughput needed, the size of the units, the size of the facility, the specific jurisdiction that you might be in. But this is kind of going to give you a rough idea of the different costs associated with each process. So again, with hydrocarbons here, I would say the costs associated with a hydrocarbon operation or setting up a hydrocarbon operation are going to typically be front-loaded. This is going to incur the most expensive facility costs because you do need to have that specific control area with adequate ventilation, with specific CID1 components, and have fire rated room. Have a buffer for fire rating, essentially prevent any fire from spreading if there were to be an issue in your operation. So the facility costs associated with hydrocarbon extractions are going to be higher than the other three processes. I would say equipment costs are kind of middle of the road. It really depends on the ancillary equipment that you want to bring into your operation. Hydrocarbon extraction units are fairly reasonable in price, especially compared to your kind of run-of-the-mill CO2 unit out there. But that being said, hydrocarbon extractions do typically require some ancillary equipment. So whether or not those are solvent-free pumps, essentially pneumatic pumps to help recover and move hydrocarbons through your extraction unit systems, whether or not you want to have subcritical freezer storage available. If you're going to be bringing, let's say, fresh frozen product into your facility, you want to keep that at maximum coldness at all times to help block out that moisture. The vacuum ovens you use, kind of the amount of vacuum ovens you need to achieve production goals, those are, of course, additional costs that you need to consider. And then again, with any post-processing refinement that you might be looking to do, if you do want to bring in a short path distillation unit, a fume hood, a thin film unit, kind of all these different options you have for that post-extraction refinement, that's additional equipment and it's going to incur additional costs. But by and large, I think just the hydrocarbon extraction units on their own are going to be on the more reasonable side when it comes to equipment costs. And then operating costs really boils down to replenishing your solvents. So while we do use closed loop systems, they're not perfect. When you are pulling the extracted cannabinoid compounds out of those systems, there are some hydrocarbons that remain trapped in those compounds, or in that mixture, I should say. There's a little bit of off-gassing that happens when you actually break that seal and open up the system to pull the extracted material out. So you are recovering large amounts of hydrocarbons, but there's a little bit that escapes into the atmosphere, which goes back to the facility costs. But also you will need to replenish those solvents as you go on in time. Energy costs are, I think, fairly reasonable when it comes in comparison to CO2, for example. The equipment energy needed to run, let's say, a basic extraction unit, it's not going to be too high. Again, depends on really kind of the ancillary equipment you want to have in your facility. And then the final ongoing cost for hydrocarbon extractions is going to be equipment maintenance and component upkeep. So hopefully you're not having to replace pressure vessels or lids too often, but there are things like gaskets and filters that are used in hydrocarbon closed-loop systems that need to be regularly maintained. So you have to go and purchase those on a regular basis to make sure that you're maintaining the integrity of your unit and keeping the quality of your output high. So supercritical, kind of similar to hydrocarbon, that a lot of the costs are front-loaded here. However, I would say with supercritical CO2, from my experience, those costs are going to be largely in the equipment itself. So the facility requirements are certainly lessened compared to hydrocarbons because you don't need that CID1 space. You basically just need to make sure there's adequate ventilation to prevent the buildup of carbon dioxide in that room. And then if you do have any sort of ethanol post-extraction processing that happens, you'll need a fume hood for that to control ethanol vapors. But for just the CO2 extracting itself, the facility costs are going to be minimal. That being said, the equipment costs are going to be much higher for supercritical CO2 extractions than the other three processes. I would say typically, a CO2 unit that has comparable throughput to its hydrocarbon counterpart is typically going to be about 10 times the cost of that. And of course, like I said, this is just kind of some brief estimates from my experience. So I'm sure folks out there have seen cheaper, more expensive units. But by and large, that CO2 unit is going to be kind of the biggest cost of setup for a supercritical CO2 process. And then there's the post-processing piece. I think folks are typically more likely to have post-processing equipment for CO2 extracts than they would with hydrocarbons. So I think it's more of a consideration when it comes to that isolation of compounds, doing distillation, crystallization, whatever process you want to do. Having the additional equipment necessary to achieve those compounds is going to incur additional costs. And then operating costs, pretty much the same as hydrocarbons here, where you do need to replenish your CO2. CO2 of the solvents generally a lot cheaper than hydrocarbons are, but you still need to source that from an air gas or kind of any sort of comparable AmeriGas type provider of gases. The CO2 you want to use is going to be kind of you want a scientific or medical grade CO2 that's very clean for these processes. So some additional costs there. I would say energy costs are a little bit higher than hydrocarbons, typically because you are compressing that CO2 into a supercritical fluid. There's a decent amount of energy requirement there to do so. So I think kind of ongoing energy costs are a little bit higher for supercritical CO2 extracts or supercritical CO2 processes, sorry. But then the equipment and maintenance and kind of general upkeep is going to be about on par with the hydrocarbon unit. So kind of the ongoing maintenance of your various components for your extraction unit. So I think ethanol is probably going to be the cheapest process described so far. I think mechanical and rosin definitely takes the cake as being significantly cheaper to set up a rosin operation than the other three here, but I think ethanol is going to be a little bit cheaper than CO2 and hydrocarbon processes. So the facility costs are really similar to the hydrocarbons, are impacted by the need for that control area to have a CID2 space and be able to control spillage and have adequate ventilation in place. And then, of course, having the appropriate fire suppression units in place and have fire-rated walls, for example, for that ethanol production room. And actually, those remind me of one thing I've neglected to mention for the hydrocarbon side of things that does apply to ethanol as well, is that the solvents that you're using do require special control areas for storage. So whether or not you're doing that inside your facility or outside your facility, there will be additional costs with setting up kind of a storage area for these solvents. So some jurisdictions that can be as simple as a shed outside, and then some jurisdictions will require you to have a similar control area to what you're using for your actual extraction processes, just for the storage of those solvents. And so that's something worth worth consulting local regulations to figure out exactly kind of what the needs are going to be for that process. Equipment costs, I would say fairly cheap. Ethanol processing equipment, because there is no massive amounts of pressure involved, no volatile solvents or anything like that. Well, not as volatile as hydrocarbons, at least. The cost for ethanol equipment is going to be a little bit lessened. Just again, I think mostly because of the pressure vessel piece. And there's not really any complex moving parts beyond having a system that can move the ethanol through your unit. So you can even have kind of a gravity-based system. You don't have to have a compressor that pushes ethanol from one end to the other. So you can achieve a relatively cheap and relatively high throughput operation by using kind of just ethanol units. But again, ethanol does require that post-processing, whereas it's a little bit more of an option for the other three processes. When it comes to ethanol, you really do want to have post-process refinement in your facility. So that's going to be additional cost for the equipment. Then operating costs, just the same as CO2 and hydrocarbons, but the energy required to run an ethanol system is typically going to be less than the other two. But you need to have similar, equipment maintenance and upkeep as CO2 and hydrocarbons. And now for the nice cheap mechanical or rosin costs. As you can see, there are no facility costs because using the pressure and temperature, you don't have to have a control space. You can make rosin with a hair press at home. So there's no need for kind of fancy facilities. One thing to consider is, of course, I think this actually applies to all the processes, having a clean room or clean space, so you're not introducing outside contaminants to your extract. But beyond that, there's no really kind of regulatorily enforced facility design costs associated with mechanical and rosin processes. You do have to buy the actual rosin press. There's, I think, over the last 5 to 10 years, a lot of companies have popped up that do manufacture dedicated rosin presses that have kind of the adequate pressure and speed of pressure applied to the bags and the right temperature applied to the bags. Actually maximize your output and the quality of the rosin you're able to extract from your plant matter. But they're going to be a lot cheaper than any of the other units that we discussed today. And then operating costs, basically component upkeep and mechanical maintenance of your rosin press. So really the only ongoing cost there is going to be those filter bags. As they get dirty and as you clean them, they lose integrity, you're going to want to replace them. All right, so that was really the bulk of what I wanted to present today. As I promised at the beginning, I did put together this table here. It kind of goes over all the different categories that we've compared the different processes in today. So moving from cannabinoid and wax, kind of what compounds you expect to receive from your extract, the selectivity, the product variance, the operating time per run, the throughput, the costs, the hazard levels. So hopefully this is a good kind of starting table to help get you thinking about the different bonuses and just the advantages and disadvantages of each process. Personally, I don't have one that's I think is better than the others. I think it really depends on what your throughput and product goals are going to be for your operation. But there are certainly some processes that are going to be better suited to specific goals. And so hopefully you can make some a little bit more informed decisions using a table like this to kind of compare the different processes. All right, so I'm going to move to see if we got any questions here that I can help with. Oh, we got lots of questions. All right, or at least lots of chat happening. This is good. Make sure I'm sorting this from the right way. So it looks like you guys were talking to each other pretty well. I'm going to start with Andy. You mentioned using nitrogen during hydrocarbon. So in my experience, nitrogen is used to push remaining solvents through the system. because nitrogen is an inert compound. You can essentially push out the remaining hydrocarbons and speed up the actual extraction process. Beyond that, I think it's really just a speed of process for using nitrogen. I can certainly kind of put together a little bit more information specific to using nitrogen for hydrocarbon extractions on the next webinar. It's been a little bit for me since I've actually worked in a hydrocarbon facility, but I know it's used to push remaining solvent through that system and just speed up the process. Sasha, yes, we are going to be sharing these slides, all of our webinars. The slides are shareable and they're recorded, so you can listen to me talk again if you feel inclined to do so. So Jared, it looks like you guys are talking about kind of the reuse of solvents. So hydrocarbons, yes, can be reused. Ethanol, hydrocarbons, CO2, those are all closed loop systems, so you can actually pull those solvents back in and use them again for future runs. Each one does use a little bit, so that's why you have to kind of upkeep solvents as you go through it. But you do, yeah. And then you get into the details about CO2. Yeah, like I said, I don't know if 10 times is exactly accurate, but the CO2 at those initial equipment costs are going to be a little bit higher than the other ones. So tetrafluoroethane. I mean, you're really making me pull out. So tetracarbon extracts, those are the ones that you, I don't know if you guys have seen kind of more the lavender colored extracts, or at least this is what I understand about it. It extracts kind of a little bit more of that purple color from the plant. Quite frankly, off the top of my head, no idea what the differences are between that and the other hydrocarbons. I will definitely do some research into that. I'm glad you brought that up. And I think, you're making some good comments here about hydrocarbons in general and just consumers. Consumer preference is really dictating kind of why these different processes exist. And then Andy, getting into these kind of more complex solvents that we're using, I really want to do just kind of an introductory walk through each process. I think one thing that I'd like to do is let's see, if you want to send me some of these questions, Andy, I'd love to actually include these in kind of the next follow-up, the part 2 of this webinar. Even cryogenic extraction. So using kind of cold frozen, fresh frozen product and having your cryogenic equipment. I think that's something worth touching upon. Maybe what I'll do is find someone that's a consultant that does kind of specifically hydrocarbon extractions, or anyone that's using cryogenic extraction, and bring them on as a dedicated show specifically to talk about that. So fresh frozen is kind of the preferred way to go for a lot of folks, because you are able to create those high quality live resins and diamonds at the end of the process that I think consumers are largely becoming more or gaining more affinity to. So I think that's something I'd like to touch on a deeper dive into hydrocarbons specifically. So I think what we'll do is put on a series of webinars that just dive into, or at least spends the whole hour focusing on each one of these processes and kind of gets into all the nuances. I know I didn't mention much about post-processing today, so that's another one that we could do. So if you want to get to any additional questions, actually here, what I'm going to do is just throw my email up in the chat. Feel free to email me any additional questions or topics that you guys like to see. I think what we'll do moving forward is move from a little bit less of a focus on the equipment and facility design and kind of focus a little bit more on the actual processes. I think that's what folks want to learn about. So we can certainly kind of make that the topic of choice for the coming weeks. And I'll be working to put together some more content so we can keep these going at a good pace. Hopefully, every other week we'll be able to put one of these webinars on and continue the educational experience here for you guys. All right, everyone. Yeah, I really appreciate you guys all joining me today. Hopefully you learned a little bit. Again, high-level walkthrough of a lot of these things. I know folks are looking for a little bit of a deeper dive, and so we'll definitely be sure to spend some specific webinars focused on each process in the future, and give you guys a little bit more information. If you guys do want the recording, I think you can find them on our website. If not, just shoot me an email or email info@extractionbooth.com, and we'll be able to get that to you. No problem. All right, y'all. Have a great rest of the day.